So today, this video is not going to be about Minecraft. It's going to be something more important than Minecraft. And if you know, I am Princess Grace. Today I'm going to be showing you a video about physics. Let me find that. Where's it? This. Nope. I was studying and then I saw this. 3D Space Force System for Engineering Machines. Let's watch this. Oh, you have to read this, okay? So, let me see. Forces in Space, Part 1.
With the Kindle app, switch from reading to listening without missing a word, so you can listen while you fight crime.
In this video, we are going to look at statics of non-planar forces. This topic is also
Statics non-planar forces
in space, and by space we mean three-dimensional space. This video is devoted to finding resultant of concurrent forces which are in space, that is in 3 dimensions, that is which are not necessary.
Okay, I'm going to show you another one. Show you this. Newton's first law of motion, examples of the effect of force on motion, video and lesson transcript. It's really good teaching. It's at study.com. You can have it at your well, let's see, Google app. It's really cool to learn new stuff.
It is easy to recognize an object in motion and an object at rest. Supersonic jets, race cars, and even my minivan can be objects in motion or at rest. What keeps an object at rest or in motion? What causes an object at rest to move? Furthermore, what causes an object in motion to stop? Well, the short answer to these questions is force, which is any influence that causes an object to change its shape or motion. For example, I must apply force to move a heavy object, such as my chair or a set of dumbbells. In fact, I have to apply a force, albeit not as much, to move even a lighter object, such as my pencil. If I press down on a ball of clay, the force of my hand causes the clay to change its shape. In this lesson, we will explore the relationship between force and motion as explained by Newton's laws. Newton's first law of motion states that an object at rest remains at rest, and an object in motion remains in motion with the same velocity unless acted upon by what we call an unbalanced force. Let's break this law down by defining some key terms. Velocity. Velocity is the speed of an object in a specified direction. An unbalanced force. An unbalanced force is an external force that changes the motion of an object. When an object is at rest or moving at a constant velocity, all the forces acting on it are balanced. For example, my cup of coffee is resting on my kitchen table as I make this lesson. The force of gravity pulling down is balanced by the force of my kitchen table pushing up on my cup of coffee. Now, if I'm to move my coffee, I must apply an external force to disrupt the balance. Thank goodness my muscles are strong enough to apply such a force so I can enjoy my cup of coffee. Ah, now that's good Joe. Newton's first law of motion is also referred to as the law of inertia. Inertia is simply the resistance to change in motion. In short, objects tend to keep doing what they are already doing. There are plenty of applications to Newton's first law of motion. Consider a car moving west along a highway with a constant velocity of 65 miles per hour. What happens when the driver takes his foot off the gas pedal? Well, according to Newton's first law of motion, the car should remain at a velocity of 65 miles per hour as long as the forces are balanced. As we have witnessed, however, the car slows down and it comes to rest. This observation begs the question, what external forces act on the car to stop its motion?
Now that was a good question. If you know the answer, comment down below and I'll show you the rest. And we learned a lot of words, new words. Velocity, and I forgot the other ones.
The answer is friction. Friction is a force acting in the opposite direction.
And friction, I just remembered. Let me redo this one. Friction. Force acting in the opposite direction of motion. When two objects come in contact with each other.
Direction of motion. When two objects come into contact with each other. Without external forces, the car would continue to move west at 65 miles per hour. Now consider a golfer hitting a ball off the tee. While the ball is on the tee, it is said to be at rest. That is, it has no motion. Once the swinging club comes into contact with the ball, the club applies an external force, disrupts the state of balance, and bam, sends the ball flying into motion. Now I like coffee, so let's see how Newton's law of motion applies to drinking coffee and driving. While the car is at rest, or even moving at a constant velocity, so is the coffee. And you know what? It stays in the cup. But what happens to the coffee if you increase velocity in a forward direction? The coffee keeps doing what it has been doing and ends up in your lap. That is, assuming...
Well, I think that was it. Yeah, I have to sign up to get another one. Now I'm going to show you a half of a video. This is 3 minutes and 57 seconds. Balance, force, definition, and examples. Video and lesson transcript. Study.com. You can take a quiz on that, a course, and of course there's the video. And I'm showing it to you. There's different stuff you can do. You can get on a lot of stuff that can teach you.
A force is a push or pull on an object measured in newtons, N. And if the forces are balanced, it means that in every direction any pushes and pulls are balanced by another force in the opposite direction. So, for example, you could have an object like this one. This box has balanced forces because it has 2 newtons pushing up, balanced by 2 newtons pushing down, and 5 newtons.
And it would be awesome if you would have taken notes about them. I think newtons sounds like an important one, so I think it is important though. But I think you need to write notes about this. It's so important. Okay, I'm gonna stop talking and let you finish the video.
Left, balanced by 5 newtons right. The forces in the x direction are balanced, and the forces in the y direction are balanced. If we did this in 3D, the forces in the z direction would also have to be balanced. But what do balanced forces mean? What's the difference between the...
Okay, so answer that one. What does balance and unbalanced mean? Okay, well, that's all I'm going to show for today. Comment down below and answer the 2 questions. And I hope I showed you what I needed to show you. And subscribe, comment down below, and touch that like button. Bye.